like highly automated musical generative AI, which kind of defeats the purpose. So there's either what we would call autoregressive neural codec models, or there's this idea of diffusion models, which is a generative model for lullabies, and the guy trained it on like short melodic lullabies for children, and the guy trained it on his like 5 or 6 year old daughter.
Hi, we are in Warsaw at PyWaw at the Venture Café, and I just got Mateusz. Mateusz is a professional musician, software engineer, researcher, and assistant professor at the Warsaw University of Technology.
Yeah. Hi, everybody.
Mateusz, what are your thoughts about AI and music?
Yeah, well, that's the big question, right? So I have some conflicting thoughts and views on the topic. So I've been a professional musician for a lot of years, so I know what's the feeling of being on stage and practicing on your instrument and like putting your like heart into music, into performance, etc. But then also like again, like a part of my heart is at research, at machine learning, at programming, etc. So I think in general, like my whole view of this whole hot topic that is music AI, is that I really like and I'm really interested in the parts that really empower like new interfaces for musical expression and really empower the artists. And I'm like not really so much like for the, like highly automated musical generative AI, which kind of defeats the purpose. And kind of it's very hard for me to like find a space where that would be like really interesting, I think.
So you said that AI has some good and bad sides.
Yeah.
So what are the good sides of it?
Well, in modern music AI, what you use the most is neural networks, and neural networks are just these fascinating pieces of maths and programming that are kind of super flexible to learn complex data transformations, like as long as you're able to express what you're trying to learn with code and maths, and you have the data to support it, you're basically in many cases able to build a tool for that transformation, right? Oftentimes better than a human would do it, right? So if you kind of think about neural networks as these, like creative machines that you can use for like audio style transfer, or that kind of allow you to explore or modify audio in ways that were, like previously unavailable. I think that's great. I think that there are also many applications in like learning music, learning to play music. So like automated, software for like vocal analysis or for tracking your piano progress or whatever. So I think like the empowering side and the new interfaces side is like really, really compelling. Mm-hmm. And then on the other side, like obviously there's this case for copyright. So again, as a performing artist and musician, I know how hard it is, to make a living as a musician. So it's getting even harder when like streams of revenue, such as royalties from your music getting played, etc. When that's being kind of compromised, or that model seems not to work the way it worked, right? Or there are these legal and ethical disputes that kind of leave you wondering. So I think like as long as we think about neural networks as this kind of next step in the evolution of musical instruments, I think we're in for a lot of super interesting, inventions and ways of expressions.
And how do musicians feel about it? Do you think that they feel threatened, or do you think that they also see opportunities?
Yeah, well, a big part of musicians, they think that the researchers are the bad guys, right? Cause the algorithms are here to like replace blah blah blah. It's all that. But musicians are also like super tech savvy people, and there's like so many musicians, among programmers. Like I'm sure that people who are listening to us right now, like many of them play some sort of instrument, right? And musicians are gearheads. They love gear. They can spend hours talking, about guitars and strings and pedals and effects and drum heads and drumsticks and cymbals and whatever. And you can argue, for hours about that. So a part of this new technology is just basically, like new cool gear that you can create like cool new sounds with. And it just, it opens up this kind of new dimension of tinkering and kind of tweaking algorithm. Sometimes it also, it kind of requires you to have a new skill set. For instance, like running Python scripts, or perhaps, like running the training of some model or whatever. Like, it's hard to expect, someone to like learn Python in full just to explore some creative possibilities. But many of these solutions, you just need to run some sort of script, right? And a couple of years ago, it wasn't super common for musicians like to do home recording or to be, like very knowledgeable about mixing technique. And nowadays, almost everybody knows, like at least a little bit, right? So that part became really like democratized and became really accessible. And I think that the cool musical technology that some of the neural networks offer, that's going to become like democratized and accessible as well.
And do you think it's because of LLMs? Because nowadays lots of people learn programming and program thanks to LLMs. Or do you think that musicians like do it just because they feel like they have to, just to catch up, like try out new things?
Yeah. And I think also it's like easier than ever to start programming, right? So if you're using like an LLM assistant, you can just, take the link to the repo or another or whatever what you don't know how to do. Just ask an LLM like, hey, how do I run this script? And if you get like a traceback and like a value error or you can ask like, hey, what's this thing and how do I fix it? So I think like getting into programming has gotten like more accessible than ever, and it's a really good time to use that knowledge and that skill for maybe something creative, right?
So musicians create music, and AI models often are trained on this music. It is published on YouTube and Spotify, etc. Is that a problem?
Yeah, that's a big problem. That's a big problem because there's like this huge legal gap right now that's being it's like a melting pot right now. So there's
how does it work? If I were a musician and I recorded a song and I published it on YouTube and everywhere, how can I prevent those companies to train their models on my data?
Well, there are initiatives like in the European Union, like the opt-out mechanism, etc. But in practice, it's not working very well. So we see that if an aggressive startup wants to just scrape your stuff from wherever you put it, they just do it, right? And so there is this interesting research area that's called data poisoning, actually. So you can kind of inject, like it's kind of like steganography. Oh, that's how I should say it. Steganography. But in like a more kind of like deep learning modern approach, right? So you kind of inject some like poison pill that makes the data either uninformative for the model, so the model doesn't learn anything from it, or even you can make the model kind of learn, something opposite to what you planned. But that technology is not well researched for audio. Sometimes it introduces artifacts, sometimes, and it has to be inaudible, right? You don't want to break your music for
Is it done by artists or is it done by those providers, for example, YouTube, Spotify, etc.?
Yeah, I don't think there's any like data poisoning that has been put into production at scale. There's a lot of interest, so it's like a research area. It's like more on like a proof of concept or like a conference paper type of level of advancement. But there's no good way of defense right now, right?
Mm-hmm.
So there's a bunch of legal lawsuits going on right now in a bunch of courts here and there. There's also no good way of reverse engineering a neural network, but this is also a research area. There are the research areas of explainability and interpretability. This is also what we do here at Warsaw University of Technology, and those are super interesting topics, not only because of the effects, because you really kind of get to, kind of demystify this black box and look into its internals and find, like the circuits that correspond to like human interpretable concepts. But those are still like researchy topics and not something that someone has already put into production at scale.
So you mentioned that the AI music is a black box.
Yeah.
So can you explain how does it work? So if I type in a prompt, if I type in anything, so like what happens in the background?
Right. So what you use nowadays is like almost exclusively neural networks. So this is like the family of AI algorithms that approximate complex transformations of data, and it's trained on data, and you use GPUs. So this is why NVIDIA is worth so much, right? But what happens actually is like audio is a complicated modality. Like for a computer, audio is like this long, one-dimensional sequence of numbers. It's like a list, right? And it's like a super long list. If you have if your audio is like sampled at a standard sampling rate of like 44.1 kilohertz, that means each second of audio is like 44,000 numbers. So in order to generate 10 seconds, you need like almost 500,000 numbers. The human ear is like very it hears very little artifacts. It's much easier to fool the eye than to fool the ear. So basically, when you're generating raw audio, what you're doing is you're modeling like very complex relationships between numbers that are sometimes like hundreds of thousands numbers. So in general, it's like a very complex task. So basically, what we've come up with is this idea, and this is probably the most sciencey thing I'm going to say today, is this idea of discrete representation learning. So basically, you have a model that kind of compresses all possible sounds into like this alphabet that you can then kind of generate sequences of and then kind of upscale that back to audio. So basically, like there's this learned latent alphabet that kind of then gets upscaled to audio. That's one of the ideas. And another idea that you might have heard of is this idea of diffusion. So there's either what we would call autoregressive neural codec models, or there's this idea of diffusion models, which in a nutshell, they take noise and they kind of distill that noise into like the precise audio you want. So these are kind of abstract and really weird ways because many people just think that neural networks just take audio and kind of cut it up like a sampling machine and rearrange the samples and like call it a day, right? So actually there's a couple of very interesting mechanisms going on. Like, I'm biased in how I think about this, but there is some like audio understanding going on, both in the like dimension of the content and like what is there in this music? Is this a low voice or a high voice, or is this a guitar or a trumpet? And both in terms of like the signal. Is the signal good quality? Is it does it have, like any noise, like etc. So there's a bunch of like signal understanding and content understanding going on.
And what are some technologies that you use for this? So, for example, can I train my own model?
Yeah.
Like locally?
Yeah.
How?
So there's if when people ask what's the first model that I could try and play with, there's this awesome model developed at IRCAM. That's a research facility, like a creative machine learning signal processing type of institution in France. And there's this model called RAVE. It's real-time audio variational autoencoder, and it's a pretty small and very fast neural network. You can train it in like a day or two, like using free online resources, on like a small set of audio, and it's a style transfer neural net. So then you can perhaps like sing into the net, and if you trained it on, for example, like trumpet or drums or something else, it's gonna try to change your voice into that instrument. And the most fun part is when you try to do like a totally out of domain style transfer, that is to kind of use an input signal that is as far as possible from what the neural network was trained on. So then you get kind of these weird results, and you also get this nice feature that rave models are kind of interactive and steerable. So there are ideas to encompass neural networks within like VST plugins, which is a very musician-friendly format. So you get your knobs, you get your keys, you get like your control surfaces you're used to. So yeah, I'd say Rave. Rave, real-time audio variational autoencoder. The original author is Antoine Caillon, and the GitHub repo is like open. Rave is pip installable, so you can just I would start over there.
And most of those are used in Python, right?
And absolutely most of those tools are using Python. I mean, there are a couple of interesting Python libraries for audio processing. Like there's the classical Librosa, there's Pedalboard, there's PyWaw if you need like low-level synthesizer stuff. If you're more on the scientific or like signal analysis side, you're gonna use, like NumPy and SciPy and those tools. Then there's all of these like little weird models developed in some weird communities of people like who are in between like creative computing and programming and music and so sometimes, of course, you spend like an hour or two or more like trying to get like an obscure repo to work, but there are many like small models that work out of the box, and in most cases they do much more interesting things than just like consuming a prompt and spewing out some slop, right?
And what is the impact of AI on the music industry? Because I've read that the concerts are getting bigger.
Yeah.
On the other hand, musicians don't like AI, and many people are afraid of it because they are threatened by it. What do you think will happen in 5 or 10 years? Do you think that AI music will become more popular, or do you think, on the other hand, that concerts and music produced by humans will be more popular because people just don't want AI?
Yeah, well, I think that like live music it's gonna be fine. I mean, people just like to see other people doing difficult things, right? So like if you go to a concert and you see like an amazing, like piano player or amazing band or whatever, like that's just awesome, right? I mean, there's just some kind of inner mechanism that makes us, find doing difficult stuff, especially in public, like super compelling, right? And I think that's not going away. I think there are some business applications where the threat is like really big. that's like, like all sorts of background music or like music for content that you don't,
it's like elevator music.
or like yeah. And and it's all fun and good, but there's a significant amount of people whose day job it is, to write music like that and create music like that, and there's nothing wrong with that, right? So there are like professional groups that feel threatened. There are people who feel injustice in terms of the royalties, right? Because you I mean, it might be a weird thing, but like artists like getting paid for their work, which is not obvious to everybody. It seems. So there is a significant amount of pushback. However, that's mostly for like the most like the most superficial kind of prompt goes in, slop goes out family of solutions, right? Whenever you start presenting these topics as like a viable extension of your like creative arsenal and like of your ways of expression, you kind of start doing like the quirky, interesting stuff, like the environments for like evolutionary composition. Like, for instance, there's this awesome lab in Iceland, the Intelligent Instruments lab, and they do like a lot of these programming environments where you process MIDI in different ways. Or there's this Polish collective named Pan Generator, which
Mr. Generator.
Mr. Generator, yeah, precisely, where they build their own weird instruments that have like touch sensitive surfaces, or like lasers, or scientists love lasers, right? So or like you play with light or other mechanisms, and there's always like a tiny bit of like machine learning or like algorithmic composition going on there, and that I think is like super important. This may not be music that gets played on the radio. It's more like music you would hear on an like an experimental festival, or in venues that kind of accept like more experimental stuff. But that community of artists, I feel, is like very curious, welcoming, and is very fast to absorb all of the technical nuances.
To me, it sounds like the barrier to participate and get paid got a bit higher, because if you need any kind of music, like you're a shopping mall, for example, you don't need an artist anymore, right? So if you're a top artist, of course, you will always get paid. The question is if it's enough, like when we compare it to other industries, but you will always have a job, right? But then like if you're just an average one or below average one, businesses would probably prefer just to generate some AI music than to pay artists.
Yeah, I know, right?
Wage.
Yeah, absolutely. And apart from that, like we still don't really know or understand like what are the like what's the legal approach? Is it even legal like to like stream an endless stream of slop in your shop or what? I mean, if you're doing that, I mean, that's your problem, I guess. But it doesn't really sound like something like like an interesting, sustainable, and most of all like a fair model for the artists, right? So it's always gonna be easier for the ones that are already big. And we've already seen this with recommender systems, right? So as people are kind of getting more and more annoyed by like AI slop and like the slopification of the internet and like bots that kind of make many portals less and less usable, right? It's kind there also has been like a bit of pushback for recommender systems because they are very kind of artificial, and maybe not always you want to be served something by an algorithm. Maybe like this kind of more traditional way of like talking about music with people who sometimes are more knowledgeable about some genre, and then you're more knowledgeable. Maybe like that's gonna make a comeback in some time. But yeah, but the bias is there not only in the applications of like the most scaled up business applications of neural networks, but also about the way we consume music and the bias in recommender systems. So yeah, it is difficult for the small artists, and like every big artist was a small artist at some point, right? So I think we should be definitely thinking about that more and more.
And what are some fun AI projects? So I heard that there is an AI song contest, so something like Eurovision for AI.
Yeah.
Can you tell us a bit more about it?
Yeah. So since a couple of years, I don't remember what was the first year actually, but since a couple of years, there's this very nice and fun AI song contest, which is called the AI Song Contest. And basically, what you do there is you submit your song, co-created with AI. And you have to use the AI in creative ways. So apart from the music itself, you also describe how you use the AI. So obviously, like a prompt goes in, slop goes out. That's not a very good submission for this.
So what is a good submission?
Yeah, like one that I remember really well was called Ada's Lullaby. So it was a generative model for lullabies, and the guy trained it on like short melodic lullabies for children, and the guy trained it on his like 5 or 6 year old daughter. So the melodies that were putting her to sleep the fastest, those were being used in the next iteration of training. And after like a couple of 100 iterations, he came up with this like personalized lullaby, and that's just awesome. I mean, I mean, like, how cool is that, right? There are also some other ideas. Like one of the winning submissions, actually, I think in 2022, was this submission that kind of used a differentiable digital signal processing model to kind of get the tuning system from a Thai ethnic instrument into like Western instruments, and like to kind of recreate the characteristics of the Thai, kind of the trills and the articulation. So like stuff like that is like extremely cool. And so yeah, the AI song contest is like one of those venues, and it got pretty big actually. I think this year in the jury there's Jordan Rudess from Dream Theater. There's people from MIT, from Berklee College of Music, and like a couple of other respectable institutions. So
and how many songs were there?
Oh, I think it's definitely in the tens, or even in the hundreds, but in the final, it's like about like 10 or 20 submissions. I think the community voting for this year's edition might still be going on. So yeah, be sure to check that out.
Planning to submit a song yourself?
Yeah,
you're a musician and an AI person,
yeah,
so
it's too late this year, but next year, who knows? Maybe me, or maybe me with some colleagues, or maybe we'll reactivate some of our older projects, or maybe with some students. We're also kind of starting to work with the musical university here in Warsaw, the Frédéric Chopin Musical University. We're working with the Society of Authors ZAIX. We're working with some other institutions as well. So it may be just so that it may happen. It may happen in the foreseeable future.
And if someone would like to learn more about AI music, what are some interesting resources?
Yeah, that's a really good question. So I think that a great place to start is the tutorials from ISMIR. So ISMIR is the International Society for Music Information Retrieval Conference. That's like the primary kind of music informatics conference. And each year there's like a set of tutorials, and those are always extremely high quality. So there's this one from a couple of years ago called Music Classification Beyond Supervised Learning. Music classification beyond supervised learning. If that's enough, I think, to find, and that's an excellent introduction to music processing and music machine learning in general. If you know a bit of Python and you even don't know anything about machine learning, that's a great resource. There's a very classical book called Fundamentals of Music Processing. I know that all books that start with the word fundamentals or introduction, those are very...
Sounds like university books.
Yeah. But introduction to fundamentals of music processing by Maynard Miller, that's one of the like golden positions. And like in general, I think like the tutorials and the stuff that gets published at ISMIR, and equally from the more kind of artsy side, there's also this interesting conference called NIME, NIME, which stands for New Interfaces for Musical Expression.
Mm-hmm.
And those are more on the art side, so that's the main focus. So they are sometimes like a bit less focused on the programming, which makes the programming part more accessible. It's a bit easier sometimes. So perhaps, like diving into some of those, ideas that have been already turned into like, interfaces for musical expression. Some of those I think that are a good place to start, and even, like see what's possible, right?
Right. So ISMIR,
ISMIR, NIME, books,
local communities of AI musicians.
Absolutely. Yeah.
Thank you for coming.
Oh, thank you for having me. Awesome.